Hey guys, and welcome back. Today we're going to be talking about the roller coaster design challenge. So, the purpose of this project is going to allow you to demonstrate your knowledge of motion, energy, and forces, as well as other areas of physics that may apply. If you could design a real world roller coaster, what would it look like? To complete this challenge, you need to think carefully about your design. Would your roller coaster work? Would it be safe? Think about the physics, the principles that are involved in the design and functioning of your roller coaster. Understanding the fundamental laws of physics is very important to the success of this project. Coming up with a design solution that takes all these factors into consideration and works reliably, safely, as intended is what engineers do. One concept that we need to understand is the law of conservation of energy, which says energy cannot be created or destroyed, rather it changes from form to form. This translates in roller coasters as constantly changing between potential energy and kinetic energy, as this graphic represents. You also need to understand Newton's laws of motions of physics. Newton's first law states that the law of inertia. The law of inertia says that an object at rest must stay at rest unless an applied force is acted upon it. Roller coasters run by this law. They must be pulled by a motor to get started. Usually they are pulled up a large hill called the lift hill. As the cart is pulled up the hill, potential energy is stored. At the top, the cart has the largest amount of potential energy possible. Through the process of converting potential energy to kinetic energy and vice versa, the ride is powered enough to run the rest of the ride. That ride will continue until another opposite force is applied to the ride, which are the brakes. Newton's second law is the law of force and acceleration. This law states that the acceleration of the system object is proportional to the net force. Other factors also contribute, such as mass and outside force. In a roller coaster, Newton's second law is a key component. When the cart begins to fall over the first large hill, gravity provides the acceleration needed to go through the rest of the ride. This force is felt by the riders throughout the whole ride. Throughout the ride, acceleration changes in correlation to the amount of forces. Changes in acceleration can be caused by friction. The acceleration, and essentially the thrill of a roller coaster, can be attributed to Newton's second law. And finally, Newton's third law states that for every action, there is an equal and opposite reaction. This means that as you push down on the seat, the seat pushes back at you. This also represents the force of your body that you feel through the roller coaster, or the G-force. Momentum is another thing that we need to understand. And so while the roller coaster moves downward and increases its velocity, the momentum increases. Momentum helps determine how hard it would be to stop a roller coaster. So it would be harder to stop the roller coaster if it has more momentum. Centrifugal force in roller coasters is when an object moves in a circle, which is effectively what a roller coaster does when it travels through a loop. The moving object is forced inward, what's called the center of rotation. It's this push towards the center, centrifugal force, that keeps an object moving along a curved path. This is going to be important to understand, and you can see the link below that you can click and watch a video on centrifugal force. So when designing your roller coaster, there are many concepts that you have learned that will be helpful and very important to apply. Concepts such as potential and kinetic energy, friction, as well as gravity. That's right, all true roller coasters are entirely driven by the force of gravity. The excitement of the ride comes from the ongoing conversion between potential and kinetic energy, which we know from the law of conservation of energy. Friction is important to slowing down the roller coaster cars, and acceleration plays a role in the experience provided by roller coaster cars as they move along the track. When engineers design objects and structures such as amusement park rides, they work with what are called constraints. Constraints are project requirements or limitations. Engineers must take into consideration these constraints in order to come up with successful design solutions. In the case of designing roller coasters, some constraints that engineers would have to consider would be practical limitations, such as available or preferred building materials, construction budget and time frame, safety measures for users, ongoing maintenance requirements. The amusement park client may also give requirements for the type of movement they want in the ride, such as upside down loops, corkscrews, specific degree turns, length of drops, or even maximum speed. They also may have to abide by safety assurance for users, such as being safe for people taller than 6 feet tall. Another basic constraint that always applies is the natural physical laws that exist in our world, such as the limits of gravity and the effects of slope, speed, and friction. And how do these concepts translate into your challenge to design a roller coaster that provides a thrilling experience and is safe for riders? Well, as we analyze some of those things that we've been thinking about, potential energy, acceleration, friction, things that I want you guys to think about are at the top of the hill, the first hill must be the highest point of the roller coaster. Cars move fastest at the bottom of hills and slowest at the top of hills. Friction converts useful energy into heat and must be minimized. G-forces greater than 1 occur at the bottom of hills. G-forces less than 1 occur at the top of hills. And to avoid failing, cars must have a certain velocity at the top of loops. And so these are all important factors that you need to think about when designing your roller coaster. So here's the basic challenge instruction. You're going to watch this short video from Teach Engineering. Now remember, your goal is that your marbles travel to the end of the coaster through gravity. And so let's design and build. So today you're going to be doing your design specification sketch. Once you complete your sketch, you're going to start building. Remember, after you build your first design, you may have to modify. Tomorrow, you're going to be conducting data collection. And finally, you're going to be putting it all together in a presentation. Make sure to read the daily instructions and use your researching and thinking skills to design before starting the build. Points to think about in your design. You need to think about the point on your roller coaster where the cars accelerate, the point on your roller coaster where the cars decelerate, points where cars have the greatest potential energy, and points where cars have the greatest kinetic energy. You also need to identify where the point where the rider experiences the G-force is greater than 1G and the point where the rider experiences a G-force less than 1G. Remember to ask your teacher for any questions, and I hope you guys have a great day.